Hi, my name is Sydney Taylor, and this is my presentation on the Memento pattern. The intent of the Memento patterns is a behavioral design pattern that lets you save and restore the previous state of an object without revealing the details of its implementation. Restores the previous state through undo via rollback. The Memento captures and externalizes an object's internal state without violating encapsulation, so that the object can be restored to this state later. The applicability of the Memento pattern is you use the Memento pattern when you want to produce snapshots of the object state to be able to restore a previous state of the object. It lets you make full copies of an object state, which includes private fields and stores them separately from the object. You use the pattern when direct access to the object's fields, getters, and setters violates its encapsulation. And this makes the object itself responsible for creating a snapshot of its state. No other object can read the snapshot, which makes the original object's state data safe and secure. The motivation for this design pattern is sometimes it's necessary to record the internal state of an object. Objects normally encapsulate some or all of their state. This makes it inaccessible to other objects and impossible to save externally. Exposing the state would violate encapsulation, which is not good because it can compromise the application's reliability and extensibility. We can solve this issue through the Memento pattern because the Memento is not transparent to other objects. The undo mechanism will request a Memento from the originator when it needs to checkpoint the originator's state, and the originator initializes the Memento with the information that characterizes its current state. Only the originator can store and retrieve information from the Memento. This is an example of a Memento class diagram. It's an implementation based on nested classes. This is available in many popular programming languages such as C++, C#, and Java. And in this implementation, the Memento class is nested inside the originator. This lets the originator access the fields and methods of the Memento, even though they're declared private. On the other hand, the caretaker has very limited access to the Memento's fields and methods, which lets it store mementos in a stack but not tamper with their state. The main participants of this design pattern is the first one is the originator, which can produce the snapshots of its own state as well as restore its state from snapshots when needed. The second one is the Memento, a value object that acts as a snapshot of the originator state. It's common practice to make the Memento immutable and pass the data only once via the constructor. And the caretaker, it knows not only when and why to capture the originator state, but also when the state should be restored. A caretaker can keep track of the originator's history by storing a stack of mementos. When the originator has to travel back in history, the caretaker fetches the topmost memento from the stack and passes it to the originator's restoration method. The consequences of using this design pattern is the app might consume lots of memory if clients create mementos too often, so it can be too expensive. The caretaker should track the originator's life cycle to be able to destroy obsolete mementos. In most dynamic programming languages, such as PHP, Python, and JavaScript, can't guarantee that the state within the memento stays untouched, which would defeat the point of the design pattern. And the good things about it is it can simplify the originator's code by letting the caretaker maintain the history of the originator state, and it can produce snapshots of the object state without violating its encapsulation, which is a pretty good thing and the main point of this design pattern. For the collaborations on the right, we have a sequence diagram that describes what's happening on the left, and I'm going to read off what's happening. A caretaker requests a memento from an originator, holds it for a time, and then passes it back to the originator. Sometimes the caretaker won't pass the memento back to the originator because the originator might never need to revert to an earlier state. Mementos are also passive. Only the originator that created a memento will assign or retrieve its state. The classic uses of this design pattern is the state in a finite state machine and a pseudo-random number generator. Each consumer of the PRNG serves as a caretaker who can initialize the PRNG, the originator with the same seed, the memento, to produce an identical sequence of pseudo-random numbers. And I have two code demonstrations. We're going to head to Visual Studios to see what the code looks like. On the right now, though, you can see what the output is. As you can see, I'll describe this pretty quickly. This is a state that contains a name and their allergy. So we have John Smith, who's allergic to peanuts. They save that state. Then we have Sarah Richards, who's allergic to cats. And then there's a rollback, which restores the state. So now the state is back to John Smith and his allergy of peanuts. And that's success after the rollback. And then the program closes. And we'll see this in action. We'll just go from the top down. First class is the main. You can see right here, there's allergies, and then you can see everything being declared John Smith and peanuts. Then this is the store. It stores the internal state with new memory, and the memento is saved. Then it'll continue changing the originator with Sarah Richards, who's allergic to cats. And then you want to restore the save state, which is the first one, with restore memento. And then once that state is restored, you're finished. And then the program writes success into the console. This right here, the public class allergies, is the originator. Here's the string name and string allergy. There's getters and setters inside of here. So for each one for name and allergy, it gets the name and sets the name value and prints it out to the console. And down here are the big features of it, the save memento. So this is where the state is actually saved at. And then this is the restore memento, where the rollback happens and the state is restored. Public class memento is the memento. It has string name, allergy. Public memento right here, this dot name, this dot allergy. And again, there's two public functions with this name and allergy that are getters and setters, returns the name, sets the name. And we have public class memory right here, which is the caretaker for the whole program, which is just a small program where you have a memento, which is of type memento. Then a memento function that sets the memento value and returns the memento. And then we have code demonstration 2, which is a little bit more involved. So the first code demonstration saved one state. This code demonstration saves a couple more states and then rolls back more than once. So there's more than one rollback is the big thing for this one. And actually for this one, just so we can see it happen for the first program. So you can see what I mean. It rolled back once. This is the proof that that happened. Then if you go to example 2, has the initial states. It's a random, well, it's not exactly a pseudo random number generator. It generates a random string that should be of length 30. It generates the string, and that is what the state is changed to and saved as. It does this a couple times, and it shows you what time each of the states were saved at, when they occurred, and then you do a rollback, and it'll restore the state from that date at that time, and the state is changed to this, and then it does it one more time, so it does it twice, and then you can see that the state is rolled back. Once more to the previous state, and then we'll go from the top down again. This one is named a little, I had the comments and some of this one's named a little bit more probably. This is the class, this is the originator, private string state, public, this dot state equals state. This counts, the console writes the lines of the initial state plus what the state is. Public void random is pretty much just is what generates the new states. After that, it generates a random string. And then it'll print out what the state is changed to. Private string, generate random string, as it has the allowed symbols right here, lowercase letters, capital letters, and then numbers. And then it has threading, and it goes through and makes the random string, and then it returns the result. Public memento save, this saves the state, and just like the last one, this is the saves and restores, and then this one is also the public void restore method. And it has an exception here. So if there's an exception of an unknown memento class, it would print that out. And this would restore it. And then public interface memento right here, string get name, string get state, date time, it gets the date. That way you can see each time it's being saved at and what time it's being rolled back to. And concrete memento is the same, date and time, string. This dot state, this dot date. Public string get state, public string get name, get date, does pretty much exactly that. Returns the state, then, or yeah, returns the state, returns the name, returns the date. This is the caretaker. How this one's different is how it stores all these methods. Is it has a list. Is what it does is to save all the methods. That's the main differentiating thing of like doing it, just saving 2 states and then just kind of rolling back just once and then having a bunch of states and trying to roll back all of them. I only rolled back 2, but you can technically just roll back to the beginning if you really want to with these kind of things. And then right here is the save and then the rollback. So it saves the originator's original state, or saving the originator state. Then you have public void rollback, which is the big thing of actually just restoring the state, and it has a try and a catch just in case if anything happens. And the memento.get name. Has history, a public void history as well. This is what shows on here of the mementos of like printing out the history of everything that you've done. So you can see all the states that have been generated by the generate random string. And then this is just the main function, which basically does everything. So you have the first originator, which is it's just called initial state. It's not any random string. I just set it as that. Caretaker, which is a type of caretaker, new caretaker originator. Caretaker you save, then you do the originator random to generate new one. You save random. After you do that 3 times, you do council right line and you do caretaker history to get the history of all the states that you have generated. Then you roll back to the council and you actually do the rollbacks twice. And as you can see, this is actually start without debugging. You can see it here. And again, you can see it here. There's the initial state, saving originator state, generates random string, state is now changed to this, saving the state, generating random string, and then the state is now changed to this, save the previous state, generate state change to that. And then you have the list, the history again, then the rollback twice. You can see it all right here. Storing tells you the exact time, state change to this, once more, restoring state, time, that's state change, and the state is changed back to that. And theoretically, you could keep rolling back if you probably wanted to. And then that is all I have for code demonstrations. These are the resources I have used. These are the links to them. And then thank you for watching my presentation.